Welcome, friends, amateurs, makers, shortwave listeners. In this episode, I'm going to finish up my discussion on the building of a BalUn. And although this is what I'm going to show you could be a BalUn, an UNUN, or a BalBal, as I don't have any ground in the vicinity. Ground is not going to mess this up any. So we can stick with our application here, and this is how you build a 4-to-1 BalUn right here. In this circuit, we have a 50 ohm source, your transmitter, and a 200 ohm load, presumably your antenna. Now, how do we get from here to here? Well, I have two stacks of ferrite cores, one up here, one down here, and I'm passing a transmission line through here and a transmission line through here, and at this end I stack up the outputs in series. So you can see that this is a series circuit right here. Basically going back to the generator, out, back to the generator, out, and to the 200 ohm load. Now, one of the key features that, if you saw this drawn as a circuit diagram, was this point here is a dead short to the source. So let's look at this. We'll call this the cold end. The cold end goes in here, goes through, wraps back, and goes into the hot end of our source. So a complete copper path right here, the dead short circuit. The dead short circuit. Now, what does this mean to the prospects of this working for you? A dead short circuit, it's right there. It's literal. It's figurative too, but it's literal. You have copper wire connecting both ends of your transmitter together. How's that work? Well, this is a common mode path that I've illustrated. Let's go back there. Okay, what I've done is I've followed from here to here to here. This is a common mode circuit because this path right here is not going through a single core, it's going through two cores. In other words, the loop here is split rather than these two emerging over here. Now let's return to the shack. Now from previous episodes that I've shown is with a core and a transmission line going through the core, it's the transmission line sees nothing of the core's bulk resistance to RF. Absolutely nothing. And I've demonstrated how if only one side of the line goes through a core and then returns to the source, that's what that would be a common mode path in this configuration. So returning to this, yes, I have both a balanced path here, a balanced path here, and yet an unbalanced connection here. Well, how does this survive key down at this end? And how does this load ever see any power? Well, following that common mode path, you'll notice that in each lead of that circuit, that short circuit in this case, I have 1,000 ohms of resistance in the upper path, one lead, and when I emerge and return, I have another 1,000 ohms of impedance that separates these 2 points over here. So basically, this generator is driving 3 circuits. Circuit 1, Circuit 2, and Circuit 3. Circuit 3 is the common mode path. However, by virtue of the ferrites, I have roughly 10 beads here and 10 beads here, and the accumulation of all their bulk resistivity adds up to 1,000 ohms in this path and 1,000 ohms in this path. So basically across the transmitter, or source, I have a 200 ohm load paralleled by a 2,000 ohm load. So yes, we still have common mode current, we still have common mode losses, but when we view it from the source, it is a 2,000 ohm load across here in parallel with a 200 ohm load over here. And the 200 ohm load is going to take the lion's share of the current from this source, and it's going to take the lion's share of the power from this source. There will be something lost in these cores here as heat, but not nearly so much as what's radiated out from this antenna's impedance over here. So that's a quick presentation of making a 4-to-1 BalUn, keeping in regards common mode issues, and the common mode issues being solved by the use of ferrites, and how the use of ferrites separates the circuits. This is what I meant about isolation. So if I return to, if I return to this circuit again, this 50 ohm load is isolated from this 200 ohm load by 2,000 ohms of resistance between these 2 points. Now, this 2,000 ohms of resistance only appears to at the short circuit part, and the power loss to it is trivial in comparison to the loads, what the load sees. So we have a parallel path here that sees nothing of this resistance, parallel path here that sees nothing of this resistance. These are balanced lines. They're balanced driven, and even though this is a series connection, they're balanced loaded. The unbalance comes in the seeming contradiction of this short circuit here being placed across both ends of your source. But 2,000 ohms appears by virtue of this now current path here, that in former times I related it as a unbalanced current. And this saves our bacon. So returning to the shack, I hope that that brings some clarity to the application of ferrites and BalUns, how the ferrites isolation keeps you from that trap of the short circuit, and how, I'm not illustrating this now, but in other BalUn designs that you find across the web, you might see another wire going outside the balanced paradigm. That wire is wrapping back to add to the voltage source at the output, and if it's handled right, in other words, if it's all done in a balanced topology, things will work fine. But if you wrap back a wire and are not careful, you're going to disturb the balance of everything, and it might seem to operate those BalUns that you find on the internet, but when push comes to shove, some of them will fail, and some will fail dramatically. I'm not going to go into those kinds of things perhaps in the future as a special topic, but I think this closes out my discussion on ferrites, transmission lines, and BalUns all as a package deal. So I hope you find that this has been instructive and useful. I hope to see you again in future episodes. So my 73 is all.